Have you ever wondered how scientists transform the raw gene expression data into meaningful biological insights? In this session, I will show you exactly how to do that. Hi everyone, welcome back to our series on gene expression analysis. This is Dr. Babajan Baranganapalli, Associate Professor in Bioinformatics, and you're watching Bioinformatics with Baby. In this video, we are diving into the most exciting part, the gene expression analysis. We'll look at how to process and interpret the CSV file generated from the GO2R and convert into the actionable results. Whether you are completely new to this or just looking for sharpen your skills, this session will guide you step by step. Okay, so when you open the CSV file in from GO2R, you will see several columns of the data, but there are three key columns are there that we all need to focus on. The first one is the probe ID. The probe ID is a unique identifier for the specific gene. However, you may have noticed that some of the genes have multiple probes. Why does this happen? So generally the probes are designed to target the different regions of the gene. Sometimes a single genes have multiple probe to capture the variation, like alternative splicing or different isoform. This generally ensure that even the complex genes are detected accurately. Okay, if you want to explore the detail of the probe, we can check the summary of the summary information for the platform. For example, in this case, we are using the Affymetrix human genome U133A array or HGU133A. So this microarray has nearly 22,277 probe covering approximately 14,000 human genes there. Okay, if you need the more information about the probes, like it exact the sequence or which particular gene has been associated, we can refer to this Affymetric website. You just need to go to the Affymetric website. We just click on this HGU133A and it will show the whole information for you. As I mentioned to you about the gene information, about the sequence information, about the chip information. Okay, all the probe information, everything, almost all the information you can get it easily from here. The second very important column is log FC. So log FC generally tell us how much gene expression has been changed between the two conditions. The positive value means the gene has been upregulated, while the negative value means it is downregulated. For the analysis, I will use the following threshold like log FC is if it is greater than or equal to 1.5, I can consider that one as a upregulated gene. If the log FC is greater than or equals to minus 1.5, then I can consider that one as a downregulated gene. So why these specific values for this particular log FC is okay? Well, a log FC of plus or minus 1.5 mean at least threefold changes in the gene expression, is considered as a biological significance. However, these values can be changed based on your study. For example, in a strict threshold like plus or minus, you can consider the log FC of 2. It might be used if you want to go for the high confident results. Uh, High confidence. So for example, if you take the cancer, so in a cancer, the expression of the genes will be very high. At that condition, you can have to take the cutoff values more to find out the highly differentially expressed genes. Or some condition, it may be we need to consider the plus 0.5. Okay, so I mean plus or minus 0.5 it could be used if you are working on the noisy sample, like for example in the blood tissues, mostly the expression levels are very low. At that condition, you have to consider the log FC value will be less than or equal or plus or minus 0.5. So the last one is the p-value. P-values tell us how statistically significant the results are. We'll filter for the genes with the p-value less than 0.05 means there's a less than 5% chances the results happen by random variation. This specifically ensure that we are focusing only on statistically significant genes. Together, together with this log FC and p-value, help us to narrow down the most important in which we call as a differentially expressed genes or DEGs. So let's open the CSV file and we will apply the filters using a threshold. As I mentioned, we'll find nearly 83 probes are upregulated and 306 are downregulated. Okay, you can see here. So I'm just sorting them by high to low, sorry, low to high. Okay, so here we found nearly 306 genes are downregulated. Similarly, we will do that one with the upregulation also, sort by high to low. So here we got nearly 83 probes are uh, upregulated. Okay, so but here an important point that since some of the genes have been multiple probes, we need to calculate the average log FC for each gene. For example, if a gene have 4 probes, you will take the average of their log FC value to get a single value for that particular gene. Okay. Okay. Now we will take all these significant probes based on log FC, paste them into your new sheet. Okay. And and again, I'm going to apply the p-value filter, which is less than 0.05. In our case, after filtering the p-value, we found nearly 27 probes do not meet the p-value cutoff. So we are going to discard them. Next, we select all the remaining genes and paste them into another sheet. Okay. So after the pasting that one, first of all, we have to select the only genes. Now again, you're going to paste that one in a separate sheet, and you can remove the duplicates. After this step, after removing the duplicates, we are left with the nearly 288 differentially expressed gene, and these are the genes we'll use for the further analysis. You can see here we applied the log FC value and we applied the p value as a cutoff values. For example, in our case, we have used log FC of 1.5 and the p value of less than 0.05 to filter down, then narrow down the variance. So here finally we got nearly 288 differentially expressed genes. One more very important features of GeoTOA is that you can check the expression of individual probes across a patient. Okay, to do this one, you just simply need to go back to the analysis page and you have to enter the probe ID like this. You can see here, I'm just copying this probe ID. Okay, I'm just pasting here and you will see instantly the values or intensity values of the each patients. Now we have the DG list, the DG list is there. Now next step is we have to perform the Go annotations. Okay, for this reason we are going to use two different tools. One is Enrichr and second one is a Cytoscape ClueGO tool. So the Enrichr is a web-based tool and it's very easy to use and it will perform the analysis very quickly and very accurately. So for this, we have to go to the Enrichr website, just to type here Enrichr. Okay. And once you go to the home page, we just need to paste the DEG list here. Okay. Keep everything as a default. We are not going to change anything. Okay. So after that, just click on Go. So after that, Enrichr will directly redirect you to the multiple annotations page where you can see here the different annotations are there. Okay. So we are going to click on ontologies. We are not going to look onto any other things. So we are just clicking on the ontologies. So I will start with the biological process. If you click on ontologies, you will see here different terms are there: biological process, cellular component, molecular function, everything is there. So I'm going to click on the Go ontologies biological process. So if it is specifically tell us the system of the genes that is involved in the particular biological process. Okay. So Enrichment display the results for us as a bar graph table, and also it will show the uh, clusterograms also it will show you. Enrichment also linked to the tool like Appetite, which provides advanced visualization like a scatter plot, marathon plot, and also the volcano plots. You can see here it will show the better representation for you compared to the any other tools. So at the bottom also you will find the table similar to identical to the table what we have seen in the Enrichment. Okay, so let's redirect again to the Enricher tool. Okay, so now we'll take a look onto the molecular function which shows the specific activities of the genes, and also the same for the cellular component. Okay, which will tell us which particular genes has been product has been located in which particular cells. This insight helps us to understand the major role of the DEGs. Okay, and also you can go back and perform the pathway analysis also identical to this one. Okay, so you can do this one the pathway analysis also where you can understand what are the different pathways has been involved in the involved by these DEGs. Okay, so you can see here there is a next option is available. We just need to click on pathways. You will see the similar results like what we have observed in what we have seen in biological process, molecular function, and also the cellular component. So in a pathways one, you see that one, it will show you different type of pathways is there, reactome, wiki pathways, and other pathways is there. We are more interested on the cake pathways. In cake pathways also, it will show you the same thing for you like the bar graph, tables, clusterogram, okay, and also you will see this appetite visualization pattern also. Okay, you simply need to go to table and you have to export this table completely. Now we exported all the 3 to 4 tables: biological process, molecular function, and cellular component, and a pathway table here. Let's open the data in Excel sheet. Here you can see the biological process ontology sheet which contain all biological process term. So the total number of genes involved in each pathways and also the overlapping genes of our list DEGs, and also you can have a chance to filter the terms based on the p-value. So as with the other analysis, we consider the term p-value should be always less than 0.05. After applying this filter, we find nearly 196 biological process terms are significant. Similarly, we need to repeat this process for the biological molecular. Similarly, we need to repeat this process for the molecular function, cellular component, and the pathways. To save the time, I will speed up the rest of the process into 2x. If you want to review it more slowly, you can adjust the playback speed in YouTube settings. So next tool is the Cytoscape Amiibo. For deeper and more interactive analysis, we have to move to the Cytoscape ClueGO. You can find this ClueGO under the application menu in the Cytoscape. Once you selected it, it will open the panel and it will show the several options for you. Okay, each explained to the help icon. If you just click on the help icon, it will show the detailed example and whole information for you. Okay, so first we have to load the genes. So for loading or setting up the gene, you just need to click on the load your DEG list here, and you can choose organism. In this case, I am selecting the Homo sapien. Okay, so and also the ClueGO will support the multiple identifier like the gene IDs, ensemble IDs. Okay, other information also it will provide. It will even if you have the full name of the genes also it will support. But the gene IDs are generally the most accurate one. Okay, we considered always the gene IDs. So and also you can do the settings, several settings to this ClueGO. So ClueGO allow you to select the Go terms like the biological process, molecular function, and cellular component and pathways. Even you can combine the multiple ontologies in one analysis. Okay. At the bottom of the panel, you can refine your analysis by applying the various filters like the p-value cutoff, which is less than 0.05. You all also able to adjust the parameters like network connectivity using the kappa scores, which really help us to identify the related terms. Now let's load our differential expression to the ClueGO and we'll perform all the ontologies. You're going to select the biological process, molecular function, cellular component, and the cake pathways. Now all the parameters we are going to keep it in a default. Okay, so once we click on start, after analysis runs, you will see the network visualization show the how the genes and terms are connected. So in this view, it looks very crowded. For this reason, I am going to break it down. For example, I'm going to consider only the biological process separately. Okay, I'm going to perform the analysis individually for the biological process, cellular component, molecular function, and pathways. Now we will first do the biological process. Okay, so here once again I'm pasting this genes. Okay, click on biological process, and same thing. You going to use all the default parameters. Okay, so once click on start, so you can see here the ClueGO able to detect the different terms involving in the different type of genes. Okay, you can click on to the cluster to explore the specific terms and their associated genes. There are several visualization options are available in ClueGO, such as you can see here the Kappa clusters is there, ontology relationships are there, and the node connections also is there. If we go to the ClueGO results tab, okay, again if you see here, of course, you will see the table displaying the significant terms along with their p-values. Okay, you can also export this result directly from this tab. Additionally, if you click on this cluster 1, you will see the graphs like bar graphs and pie chart, okay, which will help us to summarize the data visually. So this visualization also you can export it as a high resolution SVG image uh, for your case presentation or for your report. Okay. Similarly, we'll repeat the analysis for the similar cellular component, molecular function, and gate pathways. I will speed up the process in 2x for remaining step, but I will export all the results into the table for a further analysis. Okay, so once we have done that one, even with the high resolution images also, for example, if you want to save this network image, you can save this one simply by going to the file. Okay, so click here, export, and click on network to image. Here you have option to select the JPG, PDF, and the PNGs. I'm going to use the PNGs and increase the image size. Okay, I'm going to select the 500 and save it to your location where it will save the high resolution network image for you. Okay, so this is how we can perform the whole analysis. So let's see how we can interpret the result. From both Enrichر and ClueGO, we identified the most enriched pathways and the process. For example, in biological process, we have seen the immune system activation, and cellular component, we have seen the nuclear complexes are there, and molecular function also you have seen the enzyme binding. In pathways, we have seen the various immune pathways like interleukin 17 signaling and protein digestion pathways. So, by connecting these results, we can understand the broader mechanism affecting the phenotype in especially in here in this case endometrial cancer. So, what is the next step for us? So once we have these pathways which the genes are there, what exactly the next step? Actually, to validate this finding, we have to perform the functional experiment. For example, we can do this gene knockout technique to study the role of specific genes in the pathways. Okay, especially this involves in the silencing or deleting of gene. See how exactly absence of this gene impact the phenotype. Okay, alternatively, you can check the overexpression or put in interaction to further explore their role in a disease progression. Okay, and also you can verify by using the RNA-seq method or RT-PCR method the expression of the specific gene in a different type of in a specific phenotype. Okay, so these experiment is especially helpful for us to bridge the gap between the computational and real world biology, helping us to fully understand the disease mechanism. Okay, so thank you so much for joining. Make sure you subscribe and hit the like button. This is always encourage us to create more or more content like this. This is Dr. Babachan Banaganapalli and you're watching Bioinformatics and Baby.